Today we're going to talk about earthquakes. So in this first picture on the left, you have noticed that the town is just normal, nothing's happened. In the picture on the right, it's clearly an after picture, after the earthquake has happened, and clearly there was some major devastation that occurred. Interestingly enough, the bell fell in the bell tower, but the tower stood standing. So what is an earthquake? Ground movements that occur when blocks of rocks move suddenly and release energy. And those blocks of rocks are technically called faults. That would be what's represented right here, this thick black solid line with the arrows beside it. So seismic waves are going to flow outward in all directions from that. So there are two specific points that we want to talk about, the focus and the epicenter. So the focus is right here. It is the literal place where the motion of an earthquake first occurs. It is on the fault, something you must understand. We remember that because focus starts with F and fault starts with F. Now the epicenter is the location on the surface directly above the focus. Great way to remember it. Epic damage at the center of the quake. And the epic damage would be on the surface of the earth. So what causes earthquakes? Well, they're caused by deformation or deformation of the plates. Basically what happens is rocks that are under stress will stretch out and eventually they'll snap or break. When that happens, it creates an earthquake. So elastic rebound is what's kind of occurring. Imagine if you had a rubber band and you were stretching it from its a little shape like this, you were stretching it out. Eventually, that rubber band's going to do two things. It's either going to give back and go to its original shape, or it's going to break. So elastic rebound is a lot like that rubber band. So it's when a rock suddenly breaks and springs back to the original shape. So this right here is before the earthquake. The tectonic plate forces are pushing the rocks on either side in opposite directions, but they're locked together, so there's no movement occurring. When there is enough force being exerted or pushed, it will eventually give way. When it does, you get your quake. So after your earthquake, you will then notice that the plates moved and that there has been damage. Both this picture and this picture show that. This one, the road's broken because it's a normal fault. This one would actually be a transform fault. So where do earthquakes occur? They occur near the edges of tectonic plate boundaries. So if you notice right here, all of the thick black lines represent the plate boundaries, and all the little red dots represent an earthquake. If you notice, this right here is the ring of fire, this whole plate. Most earthquakes occur near the ring of fire or along other areas. Let me switch colors here so you can see. These are subduction zones, okay? So lots of subduction zone earthquakes, lots of earthquakes along the transform boundary, that's the San Andreas Fault. And then, of course, a lot along the ring of fire. So anywhere earthquakes occur, it's occurring along a fault, okay? And that's a break in the Earth's crust where the plates slide past. And about 500,000 earthquakes occur every year, keeping in mind you don't feel them until they're 2.5 or greater. So where do earthquakes occur? They occur at all three types of boundaries, but some are much more noticeable and substantial than others. At a transform boundary, that's when two plates slide past, such as the San Andreas Fault in California, you're going to get shallow earthquakes. So transform boundaries create shallow earthquakes, roughly about 50 kilometers below the surface or above. That does not mean they cannot be damaging, because they can, but they are shallow in nature, meaning they're not that far under the actual crust itself. The second type is a convergent boundary earthquake, and it's going to create very strong earthquakes, okay? Most often these are going to happen somewhere where there is subduction. And subduction often can lead to tsunamis if it's occurring near water. These can occur at depths up to 700 kilometers. So 700 versus 50 is a pretty substantial difference. The last type of place earthquakes occur is a divergent boundary. It also is going to create shallow earthquakes no more than 20 meters deep. And these are going to occur at mid-ocean ridges. So this is going to be like in, say, Iceland. Lots of little mini earthquakes that occur in Iceland. Most of those occurring along places where volcanoes are active. So the three types of faults are transform, convergent, and divergent boundaries are associated with the three faults. So we have a strike slip fault, that's fault 1. We have a reverse fault, and we have a normal fault. So a strike slip fault is going to be transform boundary motion. It is shearing in terms of its stress. And it's seen right here. It slides past, it would cut off something such as a river, etc. And it will cause damage. The second type is a convergent compression-based plate motion, and that plate motion is going to create a reverse fault. If you notice, the hanging wall is moving up in relation to the footwall, creating shortening. It's going together. It's forcing it together. The third type of fault is a normal fault, which occurs at a divergent boundary, and the hanging wall is sliding down in relationship to the footwall, creating an extension or stretching it out. And that's tension-based. So how do these earthquake waves travel? Well, there are three types of seismic waves that we are going to focus on. P waves are primary waves, S waves are secondary waves, and the third one is a surface wave. But all three of these are types of seismic waves. All right, a primary wave is P for primary. It moves the fastest. It also moves in a straight line. If you watch the picture right here, you'll notice it kind of helps it compress and expand like an accordion straight across the motion. Moves through solids, it moves through liquids, and it moves through gases. This is the first wave. That's what primary means, first. The second wave is a secondary wave, obviously, and it's the second fastest. The difference is it's not moving in a straight line. It's moving side to side and up and down, which you can see in this simulation right here. And it can only move through solids. This is really important because it helps us map the inside of Earth, because this tells us this layer cannot go through what? If you said the outer core, you would be correct, because we remember that the outer core is a liquid. This is one of the ways we were able to study layers of the Earth through seismic wave technology. All right, so surface waves are the results of P waves and S waves when they reach the surface. So they are the slowest seismic wave, and they make the ground roll like an ocean wave. So A would be no earthquake. B would be the P wave, side to back and forth motion, a little bit of damage. S wave for C is the secondary wave where it's side to side. And then the last one, D, is the surface wave. And that's important because it's going to act like it's rolling over, creating an ocean wave. So basically the ground will literally be rolling, where it's like acting like a wave, okay? This is responsible for surface damage and a lot of falling buildings. So effects of earthquakes. They are dangerous to people and to structures. Obviously, they cause buildings to shake violently and often collapse. They do cause injury and loss of life. They can also cause injury due just to collapsed buildings. And then they do lead to other issues such as gas leaks, fires, floods, and polluted water supplies. Keeping in mind a lot of newer countries are a lot of very wealthy countries, such as places like Japan that sit along the Ring of Fire where they have lots of earthquakes, they do retrofitting and they also do earthquake proofing so they can make their buildings ready to be able to withstand earthquakes of today. And they are able to not fall, but just merely shake. The last thing you need to know about earthquakes is that they trigger tsunamis. And a tsunami by nature or by definition is a series of long waves that can travel across the ocean up to 800 kilometers per hour. It starts out as just a large wave, but as it approaches the shoreline, it gets more shallow. Therefore, the water is forced upward and it can reach up to 30 meters tall. When this water piles up, it's going to force itself onto the shore, and with that comes a lot of dangerous opportunities. It can destroy buildings, it can cause people to drown, it can pollute the water, and it will create large amounts of debris with whatever was on the surface that's now being washed ashore. If you live in an area where tsunamis can happen, you would probably have a tsunami warning system. When that warning system sounds a siren, you would know to get to higher ground.